Before we get into the quiz problem here, there will be a test week after next. It'll be a midterm test. Same basis as the test you took previously in the testing center. No, can't take your own calculator or any other aid. They give you a basic calculator. We'll be talking a little bit more about what you need to know. My recommendation is that you start reviewing for the quiz. And you start maybe by looking at the quizzes that I've been giving every day. It's a good review. Look at those quizzes. Make sure you know how you could solve those. And then think about what else you need to know. Does that make sense? So that's a recommendation. Carve out the time every day. Take a look at a quiz. Doesn't take too long. If you don't understand it, come back to it the next day. Or give it a couple of days to settle in, look at it differently. Okay. Now we're going to solve a couple of inequalities and graph an absolute value function. The absolute value of 4x minus 8 is less than or equal to 12. That means that what's inside the absolute value sign has to be less than 12. It has to be greater than negative 12. Now, the way I write this, there's another way to write it, and somebody did that. That's okay. You can write it as 4x minus 8 is less than 12, and 4x minus 8 is greater than negative 12. And then now we have two equations that we can solve. And the logic is, again, is very simple. The absolute value of something is less than or equal to 12, and that thing is less than 12 and also greater than negative 12. And of course, we went through that in a simple example early in the class last time. So we can solve this. We get what? We add 8 to both sides, we get 20, we get x less than 5. And x greater than negative 1. X is between negative 1 and 5. We can graph that solution. I didn't ask you to graph it for purposes of time, but and incidentally, this is a less than or equal to sign, less than or equal. These should have been greater than or equal, less than equal and greater than equal, and so forth. So we're going to include x equals negative 1. We're going to include x equals 5. We have this interval. Now notice one thing about this interval. It's worth noticing. What's in the middle of this interval? X equals 2. That's the midpoint between the 2 points, right? What do we get if we plug in x equals 2? 4x minus 8. If x is 2, this is 8 minus 8. That's 0, right? The absolute value function is 0 here. And it's equal to 12 here, and it's equal to 12 here. You could turn that into a graph. When x equals 2, this thing is 0. So put a 0 there. When x is -1, this thing is 12. And when x is 5, it's 12. And it's an absolute value, so it's going to have two straight lines coming out of the vertex. So from this graph, and the fact that the midpoint gives us 0 up here, we can get a picture of the graph. Just worth, that's a connection, kind of worthwhile to understand. Okay, we have -3x plus 7 greater than 15. This means that it's not less than 15. Okay, if it's not less than 15, that means it's either greater than 15 or less than -15. Anyhow, that gives us then -3x minus 7 is less than -15, or it's greater than 15. If it's less than -15, that means it's like -16 or whatever. And if it was -16, that would give you the absolute value would be 16, and that is greater than 15. So you can kind of test that. And of course, if this thing is bigger than 15, its absolute value is bigger than 15. We solve this inequality. And I'll go ahead and solve this. Y'all like to do the -7 equals -7 thing. We get -3x plus 7 minus 7 equals -15 minus 7. And now it's less than or equal, not equal. If you add equal things to things, or you have something that's less than or equal to something else, and add the same thing to both, this one's still going to be less than or equal to this, right? Okay. I generally like to just go right to this step, and I don't do this. If that's helpful to you, it's fine. I do advocate that you write out this step. Reasons that I've articulated a number of times before. We get -3x less than -22. So what are we going to do? We're going to divide -3x by 3. And we're going to divide -22 by -3, sorry. And since we're dividing by a negative, we have to reverse the inequality. You might think about why that is. That's a hard and fast rule. So one way inequalities differ from equalities. Okay, an inequality differs from an equation in that if you multiply or divide by a negative, the inequality reverses. So x is greater than 22/3. Okay, do the same thing over here. We're going to get down to -3x is greater than 8. And you see I wrote the greater than sign without thinking. But I divided by the negative, got to reverse the inequality, and we get x less than -8/3. Now this is 7 1/3. This is -2 1/3. If you want to graph it on a number line, and you should do this, just because I didn't ask it on this for purposes of time, you're generally going to want to graph this. You're generally going to be asked to graph this. Okay, so we've got seven and a third. You got -2, should be 2/3. It's a greater than, so all our inequalities will be greater than or less than, no equals. And if x is less than -2 2/3, that puts us here. If x is greater than 7 1/3, that puts us here. Now there's some I'm tempted to do graphically with this, but I don't have room, so I'm not going to do it. Okay. Got a graph y equals 2 times the absolute value of x minus 8. Look at absolute value function is y equals absolute value of x. It has a graph. It looks like this. And I'm gonna, well, look it up. The graph looks like this. Graph it between -2 and 2. And this line would be y equals 2. There's your picture. And you can scale it from there. You can extend it beyond here, extend this on. It's 2 straight lines. Okay, so to do 2 times the absolute value of x minus 8, first we'll do y equals 2 times the absolute value of x. We get a vertical stretch factor of 2. So every point moves twice as far from the axis. So we have to come up to the line y equals 4. Here's our graph. Okay. Now, I've got to shift it 8 units right. Shift plus 8 units horizontally. So that means we're going to move this thing over 8 units over to here. I've got a bunch of stuff written over here. So I'm going to do a smaller graph where I show that. That big old arrow is kind of in my way too, but I'm going to find a way to work around it. Okay. So I'm going to draw my x-axis here. X equals 2 here. x equals -2 here. So my y-axis is right in the middle. Then y equals 2 line is here. So this is just a shrunk down version of what I did here. The y equals 4 line is here. So I'll use a different color this time. Make it yellow. This is a graph of y equals 2 absolute value of x. You should know that the toolkit graph is y equals absolute value of x. Now we got to move over to x equals 8. There's 2, 4, 6, 8. So let's just say I'm exaggerating a little bit. 8 isn't quite out this far. There's x equals 8. We draw our put this in a box. We draw the same box over here. And right here is the graph of y equals 2 times the absolute value of x minus 8. This box is the same as this box. It's 4 units wide, centered at the x equals 8 line because that's where the vertex goes, which means that this is a line x equals 10. This is a line x equals 6. If we did y equals 2 absolute value of x plus 8 minus 4, we'd have to take the thing 4 units down. Okay, so that's the use of transformations, and we got to keep using them. You really need to understand it, as you're going to find out early next week when we do it with quadratic functions. On the assignment that was due yesterday, the time should have been 11:59, the cutoff time, but somehow I missed editing that. I got an email that evening, said, hey, this thing cut me off. And I realized that I needed to edit that thing, so I edited the thing. So I've actually moved that assignment. Most people have done it. I've actually moved that assignment 2 days later, in case you didn't get to finish it. Okay. And also the video for last time, I didn't get posted till last night when I got an email saying, hey, where's that video? Okay. So for both those reasons, that assignment has been moved to Friday. Don't wait till Friday. I mean, get it done today if you can. There are a couple of assignments over the weekend. A couple of assignments over the weekend. Well, we're going to go over what you need to know to do those. The y equals x cubed graph, you should remember, has a graph shape something like this. Is that familiar? If it isn't, go back and review the first section of the book, first assignment. But we'll see why here in a minute, because we're going to make a table. Now, somewhere in the middle of the table, I'm going to let x equal 0. Then y equals x cubed, well, 0 cubed equals 0. Down here, I'm going to put 1. And you're probably going to tell me that 1 cubed equals 1, right? Because 1 times 1 times 1, okay? Now, if I put -1, well, if it's an x squared graph, -1 squared would be 1, right? What's -1 cubed? Show me with your fingers. I don't see one person got a finger up. Okay. Write it out. Cube -1. Okay. I'm seeing result of overuse of calculator all over the place here. About half the class couldn't do this. Couldn't cube -1 without reaching for a calculator. -1 cubed is -1 times -1 times -1. Well, I'm going to put an extra set of parentheses here. And I'm just going to go -1 times -1. Not everybody knows what -1 times -1 is. And this is a fatal indictment of our educational system. Okay, if you have any algebra at all at any time in your life, and you've been in this course for as long as you have, if you'd actually been taught anything in your algebra class, which is sometimes the case, but more often appears not to be the case, you would know what to do here. Okay. So you multiply -1 times -1. Well, what's 1 times 1? It's negative. No, it's 1. Okay. Right? And what do you get when you multiply a negative by a negative? Show me with your fingers. Get a positive. Those are rules. Those are basic rules that you learned before, probably in 6th grade. Okay? At least by middle school. I'm not saying there's anything wrong with you because you don't know how to do this because you're smart people. I'm saying there's something wrong with an educational system, puts a calculator in your hand and never makes you think about what you're doing. Okay, anyhow, we have 1 times -1. Okay, what's 1 times 1? 1. And what's a positive times a negative? It's negative. Okay, I'm gonna put in 1/2 here. What's 1/2 cubed? Write it out. Show me the calculation. Not something you put into a calculator. If it's 1/283 cubed, feel free to use the calculator. I won't object. If it's 1/2, and you use a calculator, somebody needs to be re-educated, and it's whoever designed the curriculum you came through. It's probably a mathematician. I'll just point out that we're in global competition with countries that actually educate their students. And really kind of on you to get educated, because they're terrible deficient, especially in mathematics, where people use calculators instead of learning to think. And your teachers pretty much have no choice but to allow that to happen. Okay. So anyhow, let's do this. Okay, there's 1/2 times 1/2 times 1/2. Now, here's the number line. Where is 1/2 on the number line? Just show me. Here's, okay, do this. Here's 0, here's 1. Now show me where 1/2 is going to be. Halfway between, right? Now, what's 1/2 of that? So show me 1 and show me 1/2 and show me where half of that is. It'll be halfway, right? So what fraction is that? This is 1/2 because it takes 2 of them to make 1, right? How many of these does it take to make 1? Obviously, takes 2 of these to make a half because it's halfway between, and then take 2 more to make this half, right? So that has to be 1/4. So that's 1/2 of 1/2. Now we got to do 1/2 of that. So where's that going to be? If 1 0 is here and 1/4 is here, what's half of that? Well, go twice as close. And it's x equals 1/8. So 1/2 cubed is now the rule for multiplying fractions is you multiply the numerators and you multiply the denominators. We did an exercise on that at the very beginning of this class, because people's inability to do fractions is a big hindrance in what's coming up in a couple of weeks. Okay? So you want to review the rules for fractions, because when we start doing it with symbols, you're not going to understand a thing you're seeing. You have to know the rules for fractions and you have to work them out. You can't just look at it and understand it. You have to write it out. And you have to write out what rules you're using. 99% of the people have to do that. And the rest of the 1% generally have IQs over 140. Okay. So negative 1/2 cubed it's negative 1/8. Okay. Are you beginning to see why, when we constructed graphs of toolkit functions, I was asking you to go do a lot of halfways? Think about it. Okay. is we're going to do it again. Here we have right now, I'm just going to graph numbers in this table. I'm just going to construct them in a rectangle. It'll be a square, but a square is a rectangle. Okay. My y values go from -1 to 1. How many divisions do I need here? If I divide this rectangle in half, I get x equals 0, which coincides, which is the y-axis, okay? And if I divide it in half this way, I get y equals 0. That's the y-axis. Okay. Now, I want to get x equals -1/2 and x equals 1/2. Well, 1/2 is halfway from 0 to 1. Right here's x equals 1/2. And similarly, right here's x equals -1/2. You got to get y equals -1/8 and y equals 1/8. How are you going to do that? Well, I just showed you. You go from y equals 0 to y equals 1, cut that in half. Then from y equals 0 to y equals 1/2, you cut that in half. That's y equals 1/4. Cut that in half. And you got the line you need in order to graph the cubing function. Actually, the simplest possible graph that shows the behavior of the cubing function. I assert that this is the simplest possible graph that shows that behavior. Okay? It gives you the shape of the cubing function, of any cubing function. Okay, well, down here, you're going to divide this to get y equals -1/2. -1/4. And -1/8. Now let's make sure we understand the y equals 0. I'm going to make this y equals 0 line horizontal because that's going to be the x-axis. We'll make this line, okay, solid. So y equals -1/8 is this line right here. So where is the point -1, -1? Well, it's on the x equals -1 line and the y equals -1, x equals -1 line, the y equals -1 line here. And 0, 0, it's right here. And 1, 1 is right here. Okay? Got that? Now, show me on your sketch where these 2 points are going to be. Okay. The point here is that x equals 1/2. Where is x equals 1/2? Here's the line where x equals 1/2. Actually, that's -1/2. Here's the line where x equals 1/2. Now, if you draw this properly, from y equals 1, you're going to cut the distance from 1 to 0 in half. And that gives you y equals a half. Cut that in half, you get a fourth. Cut that in half, you get an eighth. Okay? So that the y equals 1/8 line, half, fourth, and eighth, is like here. And the y equals negative 1/8 line is like here. Again, if you're at negative 1, y equals negative 1, and y equals 0, halfway to 0, you get negative 1/2. Halfway to 0 from there is negative 1/4, and halfway to 0 from there is negative 1/8. So that the x equals negative 1/2 and y equals negative 1/8 lines intersect like here. And the x equals 1/2 and x equals 1/8 lines intersect here. Which means that your graph has to curve up like so. It has to become almost level, and then it's got to curve on up from there. Okay? It's got to, for an instant at the origin, it's got to actually level off. If we wanted the y equals 1/4, or x equals 1/4 line here, just go twice as close to the y-axis here. We did x equals 1/4. 1/4 cubed is 1/64. Now, from 1/8, if you go halfway to 0, you get a 16th. Halfway to 0 from there is a 32nd. Halfway from 0 from there is a 64th. So you got to go 8 times closer to the y-axis to get this point. 8 times closer than this point than this point. It's practically on the y-axis. And it keeps getting closer and closer. In the first quadrant, then, we have the 1/2 line, the 1/4 line, the 1/8 line. So your graph has to go through these 3 points smoothly, meaning it starts off very level, comes out here, then goes up pretty quickly. Does that make sense? Now the question is, what happens if we went out to y equals 2? X equals 2, I'm sorry. Here's x equals 1. What happens if we got to x equals 2? How far up do we have to go? Well, what's 2 cubed? Show me with your fingers. It's 8. 2 times 2 is 4. 4 times 2 is 8. 2 times 2 times 2 is 8. People want to do 2 times 3 because there are 3 of them. Okay? And that's real common, so don't feel too bad, but fix it, please. So if I go twice as far from the y-axis, I've got to go 8 times as high. Well, 8 times this, there's 1, 2, 3, 4, 5, 6, 7, 8. Just about as high as I can reach. If I go out here, I've got to go that high. So this graph continues getting very steep. Okay, if I go to y equals x to the fourth, okay, what I'm saying then is x cubed is very small, close to zero, and then it gets very big. Very quickly, but not as quickly as an exponential function. We'll find that out later. By comparison, the y equals x to the fourth power would be here, here, and here. Looks a lot the same, but it's a lot lower between 0 and 1/2. Okay? And it stays lower than this graph forever. Okay, so that would be x to the fourth. Well, one thing you probably saw in one of the open math assignments is an x cubed graph that looks something like this. Can you see that whoever did that must have done it late at night on a bad day? Because I'm sure I hope they know better. Because most of the people that do these contributions are pretty good, okay? Somebody did something like that. It's got to be flat at the origin, and any power function has to be flat at the origin. Now that took a lot longer than it should have. But the point is this now. Let's say you have a function like this, x cubed plus 5x squared minus 7x plus 2. For large values of x, so this function, the x cubed dominates whenever the absolute value of x is large. And I could have said for big negative x, the value of this is much closer to 0 than the value of this. Open Math will talk a little bit about that, but they'll probably just give you a rule. This says if you got 100 here, negative 100 here, then the line negative 1,000,000 here, and y equals 1,000,000 here. Well, 100 cubed is 1,000,000. So this point will be on the graph of y equals x cubed, and this point will be on the graph of y equals x cubed. The shape of the graph of y equals x cubed is this. When you go halfway to the y-axis, you get 8 times as close to the x-axis in the graph as this basic cube shape. Okay? So if this is a graph of y equals x cubed, the graph of y equals x cubed plus 5x squared minus 7x plus 2 is practically the same. Until you get in here pretty close to 0, and then things can happen, and then it becomes pretty much the same. And what happens in here close to 0 is one of the things that we study with polynomials. Turns out, and we already did this in the support course, near 0, they can do stuff like this. Or like this, which looks kind of similar, but it's a little different. And it's not hard to figure that out. In this case, the function we have, we expanded it, but I don't have it on the board here. This is a graph of a function kind of like the one I gave you. It has an x cubed in it, okay? There are places where the graph passes through the x-axis. There can be up to 3 points where the graph passes through the x-axis on a function like the one I wrote down here, an x cubed plus a bunch of stuff. Okay? After it gets through those points, the x cubed just takes over. So what's happening is here, the thing is rushing to catch up to the x cubed function. It's going to pretty much follow it the rest of the way. Over here, it's rushing to catch up to the x cubed function. Since we're going to study polynomials next week, it's important to understand how your power functions behave, because these power functions, the power function for the highest power tells you the overall shape of the graph. Doesn't tell you what happens in here, tells you what the overall shape is. Let me just put a little bit more here about the y equals x to the 4th. If we were to extend this into negative values, since the 4th power of a negative number is positive, it's gonna act just like, I wasn't using that color, was I? That's what the graph of x to the fourth is gonna look like. Okay? Now, if you have an even power, that means you're multiplying an even number of negative numbers, if you evaluate it for negative, right? So the numbers are always going to come out positive. And the graph is always going to look something like this. If it's a polynomial, well, it could have some wiggles in here. Okay? X cubed graph, or next to the fifth graph, or next to the seventh graph, x to an odd power, you're going to have an extra negative on there, and you're going to have negative y values to the left of the y-axis. The bigger the power, the flatter the thing gets. Your x squared function, to contrast with the x to the fourth function, your x squared function would go through this point and a point here. So your x squared function would be much gentler. There's your basic squaring function. Okay, just the shape of a square. It's not very well drawn, but you see how the fourth power gets a lot flatter. Sixth power would be even flatter than that. And eventually they almost look like this. You know, they keep flattening out. They keep approaching this corner. You go up to x to the 100th power and it looks almost rectangular. Okay, well, I think we're likely to be out of time. Perfect. Okay. Now, I had originally assigned quadratic functions for next time. But when I realized that people weren't able to cube -1, I had to digress. But what I've told you should give you a pretty good perspective on the power functions. Okay? So, good luck with that, and email me if you have questions.